Okay, so you have your PowerPoint in front of you and something to write with. You won't need a calculator. We're going to go through this kind of quickly so that you'll be ready tomorrow to do some free body diagrams in class. So we're going to start talking about forces. This entire unit will all be about forces and how forces affect the motion of objects. So first of all, what is a force? We define a force as a push or a pull that one object exerts on another. So the push or pull part, I think you get that, right? So you push something, you pull something. What I need you to understand is that there are two objects involved. There's the one that's pushing and the one that's receiving. So you can't put a force onto nothing and you can't receive a force from nothing. There are always two objects involved whenever you have a force interaction. The forces are going to be measured in newtons, so that's something that's familiar to you already. We've dealt with newtons before, so I just want to remind you that forces are going to be measured in newtons. And a newton is a kilogram meter per second squared. So that's what a newton is equal to. Forces are vectors, so we have to treat them like vectors. We're going to draw them like we draw vectors, and you guys know all of this, so this is all a review. The length of the arrow is going to represent the size of the force, and the direction of the arrow is going to represent the direction of the force. When we draw our forces, we will be drawing them coming out of the middle of the object. So when we draw them, we're going to be drawing things called free body diagrams. A free body diagram is just a picture of the object with all the forces that are acting on it. That's what we call a free body diagram. So first you have to draw the object. So let's suppose the object is a wagon. And then you have to draw the forces that are acting on it, and you want those forces to originate from the center of the object. So let's say, for example, there are 3 forces acting on this object. So you would draw each of the forces coming from the center of the object and outward. Even if the force isn't actually being applied right at the center, we draw all of our forces coming from the center of the object. We would also label each of these forces with whatever it is. So if one of them is weight, the one that's going downward looks like it could be weight, so you would label that weight. This one here might be friction, and that one might be the person pulling on the wagon's handle. Whatever it is, you would label those forces. If you had values for them, you would label the values also. So before I go any further, we're going to start talking about, there's actually basically 4 or 5 main forces that we put on every free body diagram. So we're going to go through the forces, how we draw them on the diagrams, and then that way tomorrow when we're drawing the diagrams, you'll be ready to go. The first one's gravity. Every free body diagram you draw will have the force of gravity on it. This is the force that pulls, it's a force that pulls 2 objects together. We've already talked about gravity as an acceleration, but it's going to be, now we're going to talk about gravity as a force. We're going to treat gravity as the force that the earth is pulling down on the object. So it's always going to be pointing downward. And we're also going to call that force weight. So the force of gravity is also called your weight. And so when you say you weigh, 500 pounds or 700 pounds or whatever you weigh, that's really what you're really saying is how much the earth pulls down on you. And we're going to symbolize that with a W. So whenever we draw this downward force that you can see drawn over here on, let's see, there we go, on the box, the surface, the box that's sitting on a surface, this is going to be considered the weight, and you would label it W, and if you have a value for it, you would give it a value. So if they tell you the box weighs 10 newtons, you would label 10 newtons here. So everything needs to be labeled whenever you draw a free body diagram. There's no drawing arrows that don't have labels on them. You need to put at least what the force is if you don't know what the value is. It's always going to point downward. So weight will always point down, and we'll say down is the bottom of your page, really, is the way to think about that. So however you draw your free body diagram, towards the center of the earth is going to be the bottom of your page. I want to point out one other thing for weight, which is how we calculate the weight. This is an important formula right here, and I don't want to skip over it. Weight is anything's mass times gravity. Gravity being 9.8 meters per second squared when we're on Earth. So your mass in kilograms. So if you have a mass of 70 kilograms, your weight is going to be 70 times 9.8, which will be 600 and something. I think 686. That's newtons. So that would be what your weight is. So it's your mass times your gravity. You're going to need to know this because sometimes they won't tell you the weight of the object, they'll tell you the mass of the object, but you can calculate the weight. It's very easy to do. You just multiply times gravity. All right, the next force that you're going to draw is a surface force. We also call it the normal force. Normal is a math term that means perpendicular. So we call it the normal force because it's always going to be perpendicular to the surface. This is one of these forces that you will have if the object is sitting on a surface. So if you're sitting on a surface, the surface is going to be pushing up on the object because the object pushing down on the surface. And that force is called the normal force. In order for you to have the normal force, the object has to be sitting on a surface or touching a surface. If it's not touching a surface, then you're not going to ever draw this force. The symbol for it is F with a letter N, N for normal. That's the symbol we're going to use. And it's always going to point directly 90 degrees away from the surface. That's where the normal part comes in, the 90 degrees away from the surface. Normal meaning perpendicular. So for this box sitting on a surface, it has a weight pulling down and a normal force pushing up. Now I have set these two equal to each other, which you may not have, that's not something I necessarily said, but these two in this case will be equal to each other because this box is not moving anywhere. And when it's not moving, we definitely know that it has balanced forces acting on it. That's a situation called equilibrium, which we'll talk about more later. But I just want you to start to recognize that when you have something that's not moving, then it definitely has all the forces have to balance each other out. Okay. So the next force is another one that you won't have unless you have a rope. So tension is this force along a rope or a string. So if you don't have a rope or a string attached, then you don't have to have tension and you don't have to worry about this one. If you'll notice here, this little yellow-orange color represents the rope or the string. So the person would actually be pulling along the rope, but I drew the force coming from the center, parallel to the rope. So the symbol for tension is T, and it's always going to be pointed away from the object along the direction of the rope. Whatever the direction of the rope. So from the center of the object, but along the direction of the rope. So we have now this box that's being pulled, has a weight down, a normal force up, and a tension off to the side. We'll also draw the direction of motion, which is not a force, but we like to draw those off to the side, up and away from the actual object. Lets us know what direction it's moving. So those are tensions, only if there's a rope or a string. The next one, the next force is friction. Friction is another one that is dependent on whether or not the surface is rough. If it's a smooth, frictionless surface, then you don't draw friction. But if it's a rough surface, then you're going to end up drawing that. It's a force. Friction is a force that happens when two surfaces rub up against each other. And it's going to always want to slow the object down, so it's always going to point opposite the direction the object's trying to move. So if you're trying to take a rope and pull this object to the right, so I have the direction of motion to the right, then that's going to make this friction be to the left, because it's always opposite the direction the object's moving, because it's always trying to slow the object down, so it wants to pull against the motion of the object. The symbol we use for friction is lowercase f. So lowercase f for friction. The last category is kind of a catch-all category that applies to any force that isn't one of the other ones that we just talked about, and that's applied forces. Applied forces can be in any direction and have any value depending on what's happening. So if you have somebody that's pushing this big box, we would say that he's pushing with an applied force to the right because of the way it's looking here. He's pushing to the right. So this box would have a weight down, a normal force up, a applied force pushing to the right, and assuming he was actually making the box, well, whether or not he's not, is or not. If he can make the box move there, then there'll be some friction to the left, assuming this isn't a frictionless surface. And the symbol we use for applied forces, any other force that's not one of the others that I just talked about, is just F-app for applied. Alright, so here's the steps for drawing the free body diagrams. You're going to draw the object first, then you're going to draw the weight downward and you're going to label it with a W. And if you have a value for it, you're going to give it a number value also. Then you're going to, if the object's sitting on a surface, you're going to draw in the normal force away from the surface and you're going to label it Fn. Okay, up and away from the surface, 90 degrees. If the object is moving, you're going to draw in friction opposite to the direction of motion, and you're going to label it. And you'll label it lowercase f. So if the object's moving to the right, friction would be to the left. If the object's moving up, friction would be down. So if there's any sort of friction surface, you're going to label that. If there's a tension in a rope, then you're going to label that. If there's a tension or any other applied force, you're going to draw that in and label it. The tensions you're going to label with capital T. Other applied forces will just be F-apps. Okay? And that's going to be how we draw a free body diagram. So you follow these steps, you'll get really good at drawing them. Won't be a problem at all. The next video I'm going to give you is going to be the rest of this PowerPoint, which is going to be examples for drawing free body diagrams.